Hi everyone who's just joining. We'll give everyone a bit more time to join in. Okay, I'm going to kick off and people can just pop up as they arrive. Welcome everybody. Thank you so much for joining us today for our customer only webinar, one in a series we're going to be doing. This is all about how we can predict and prevent software incidents by looking at maintainability and why maintainability matters more than ever. So a few housekeeping things. The session will be recorded and we'll send the recording and the deck afterwards. So you don't need to absorb every bit of information on the slides. You'll get everything afterwards. If you have any questions, please drop them in the Q&A section and we'll have a time at the end to answer as many of those as we can. So if you've got anything ready now, feel free to put it in now, or if things pop up as you're going through the session, please add them. And anything else I need to say? I think that's it. I'm just going to give you a quick rundown of what's coming up, and then I'll pass over to our speakers. So you'll see me, I'm Lula, I'm content lead here at Blue Optima. You'll see me pop in and off the screen. And what's coming up, we're going to look at what is maintainability. So this might be something you're familiar with, or it might be a concept that you're only just hearing people talk about. So we're going to make sure that you leave really being clear about what that is. How does it indicate and impact risk, tech debt, velocity, and cost? So why is it important? Why does it matter more than ever? Then we're going to look at how you can use your metrics, your Blue Optimum metrics, to improve maintainability, monitor it, keep your code healthy. And then we'll go over to your questions in the Q&A section. So I'm just going to pass over to your speakers to introduce themselves. Some of you will be familiar with some of these faces, I'm sure.
Hi, everyone. Thanks for joining. So I'm Guillaume. I'm lead product manager at Blue Optima. I'm in charge of all flagship products, Performance Insight. A bit of background. I'm from software engineering. I've been spending more than a decade now in B2B SaaS product, especially in complex operational realities. What I do at Blue Optima, I help engineering organizations to rethink how performance is measured and improved, especially in this new world of AI. I'll be happy to guide you in our products, especially on maintainability.
Hi there. So I'm Usman Khan. I lead the professional services team here at Blue Optima. And the core function of professional services is to help clients like yourself make maximum out of the data that Blue Optima provides in conjunction with the other telemetry data that you have in order to make the maximum of your software engineering transformations.
And finally, my name's Beth Twigger. I'm the Customer Success Director for Americas and APAC. I'm responsible for ensuring that our enterprise customers get value from the Blue Optima data and understand how to operationalize it. And so today we'll be very much focused on looking at how we can action and improve maintainability and some of the interesting industry trends that we're seeing across our global benchmark as well.
Okay, thanks everybody. So a lot of this presentation is going to be based on data that hasn't actually been published yet. So you're getting a sneak preview of our latest white paper that's coming up, and we'll also be sending that to you after the webinar as well. Before we kick off with the presentation, we thought we would just have a quick poll just to kind of gauge where everyone is in terms of what they understand about maintainability. So there should be a poll popping up in your screen. If you can just put your answers in there. And the team will respond. And yeah, there'll be a couple of these popping up across the session. So just feel free to engage so that it's not just you guys sitting there listening to us. We'd like to hear from you as well. Okay, so I'm going to now pass over to Usman and Beth, who are going to talk about what maintainability is and why it matters.
Okay, so as many of you may be familiar, but there might also be some people here today who will benefit from just a quick definition around how Blue Optima defines maintainability, and especially how it looks in terms of difference with other metrics that we provide, such as aberrancy. So ultimately, the way that Blue Optima measures maintainability is to show how easy or efficient it is to actually understand a file, and then to consequently be able to modify or review changes to that file. So we calculate that by looking at a variety of different static source code metrics and generating a rule sets based approach. So for each language and each metric, there's different rule sets that are based off of Blue Optima's global benchmark. Now, that global benchmark is over 800,000 enterprise software engineers, over 13 billion revisions, and 90 plus languages. So you can be assured that the benchmark that is underlying these rule sets is a very robust one that is reflective of large enterprise engineering practices. So we'll look at patterns around things like the volume, the complexity, and the interrelatedness of the different files, and then use the rule sets or the distributions that we see across enterprise code bases to determine what is effectively normal for a file in any given language. So what can we expect in terms of the number of methods, the cyclomatic complexity, or the interrelatedness of a file in each given language? And maintainability then effectively measures how far away from the norm does a file sit. So we can quickly start to then identify what are some of the underlying patterns that are causing lower maintainability. And as we've come on to show in this webinar, what are some of the bigger impacts that can then have downstream in your software development lifecycle? So this is somewhat different to when we commonly talk about quality. So quality is often, does the software work as expected? Do we see bugs or issues with that code? But maintainability is the kind of the precursor or the condition that makes quality easier to maintain and sustain. So actually looking directly at the source code itself prior to any negative outcomes. How this differs with something like aberrancy is that aberrancy is looking at the commit level within a file, whereas maintainability looks at the file as a whole. So I always like to use this example where, let's say that Usman and I are working on a file together, and I make a really high aberrancy change. I don't follow single purpose principles. I introduce a God object, tons of complexity and interrelatedness. I would get a high aberrancy score for my commits. Usman then comes along and says, good grief, what has Beth done to this file? He refactors it, splits it out, follows those best practices in terms of coding structures. Usman would then get a very low or even 0% aberrancy score because he's brought the changes back into an expected range. So I get the high aberrancy, Usman gets the low aberrancy, and then the maintainability measures where the file ends up after all of these changes, so its current state. So hopefully, if Usman's fixed all of my problems, which he is excellent at doing, then that maintainable file would stay in a good place. If Usman didn't come and fix those problems, the file would end up in an unmaintainable state. So the maintainability is focusing on the state of the files immediately prior to any subsequent changes. So a good way to think about that is aberrancy is good from a people perspective. How can I coach a particular engineer on best practices? Maintainability is great from a code-based perspective to understand where do we have higher risks or do we want to focus our technical debt efforts. So hopefully that gives people a high-level understanding of the metrics. Obviously, if you do have more detailed questions, reach out to your customer success manager. If you're not sure who that is, then just drop us an email at support@blueoptima.com. We'll find you the right person. And we've also got some great information in our knowledge center in the UI with more detail on those metrics as well.
Thank you, Beth. And just building on that particular definition, we do see maintainability becoming far more important now than ever, right? So we have been speaking of this, looking at software engineering performance from productivity and maintainability perspective for very long, but the effects of poor maintainability are starting to materialize much more now, as we see in the data. So as we see in this particular chart, and this is something you may all have seen in the global benchmark reports that Blue Optima publishes, uh, one thing that we do need to acknowledge is that the productivity and the Gen AI period, if you look into the extreme right hand side in the top right quadrant, that is 2023 onwards. And what we clearly see a rising trend in your productivity. Productivity is going up. And this is something you, as an engineering manager, maybe objectively measuring within your teams that the efficiency is improving. And that's all positive side of this, right? There is one another trend that is decreasing sharply recently, and that maintainability is going downwards. If you see just the bottom swim lane, that's where we see from quarter two of 2025, maintainability has started to take a massive dip, and it's going down. What this really means is that now with AI, teams are producing more output. They're getting better, right? That's good. But that code base in itself is becoming much more harder to understand, harder to maintain, right? And this code that is being produced, whether by AI or humans, right, is fundamentally the intellectual property that your business owns, right? And it's not a very ideal position to be in if the code that is an IP of the business, it's harder to maintain or harder to understand, right? AI can help us produce more code faster, but it will not absorb the business impact of being wrong, right? So that is exactly where maintainability becomes super crucial, because that's where human in the loop needs to understand and take the risk of the code being deployed to production.
Yeah, I think that's a really critical point. Is well, actually 2 points really. One is there's obviously a lot of hype on LinkedIn and within the media about the productivity gains that you can see from generative AI, and we see those productivity gains in our benchmark. That's fantastic, but it can't be all upside. So there's very much this focus around making sure that we've got the right controls and quality, whether that's being handled through human in the loop or through very specific AI capabilities that look for these quality issues using tools like Blue Optima to identify these patterns. So making sure that we keep expectations in line in terms of what's realistic and feasible. And then the second part around this being with that productivity gain, making sure that we're keeping things in line with enterprise benchmarks. So this benchmark that we're showing here is all from large enterprises, typically average customers around 1,500 developers. So when we see the sensationalist posts around 10x developer productivity from Gen AI, yes, maybe that person who's working alone in a code base that only they need to understand, and it's a bit of a pet project, is going to see a very, very different experience and a very, very different outcome to where we're working in a large, complex enterprise environment. So ensuring that we keep those expectations in line from a productivity gain perspective, but making sure that we don't get ahead of ourselves when it comes to the quality aspect, and indeed also the security aspect as well, with things like hard-coded secrets.
Now, I mean, why this is becoming a problem, right? So what we did is from within the global benchmark data set, across the large enterprises in the Blue Optima's global data set, what we are really seeing is that the software incident frequency is growing massively. And not just growing, the ability to resolve those incidents quickly is decreasing. So if we just look into this particular chart over here, what this represents is how many software incidents were reported quarter on quarter from 2023 onwards. And if we just look into the quarter one over here, the incident frequency grew from 119 reported incidents in quarter one 2023 to 359 incidents within quarter one 2026. So that's not a small fluctuation. That is a whole major shift in how software is being developed, right? And we're seeing these frequency increasing quarter and quarter. If you just look into these two main quarters, quarter two and quarter three of 2025, all blue bars are 2025. It's hard to ignore them because they have far exceeded 400 incidents every single quarter. And what these particular numbers, what used to be kind of a normal spike for 2023 and 2024 has became a new norm for 2025, right? So your incidents have gone up, and the recovery times as represented by those dashed lines have also gone up. So what this really is saying that it's just not that software incidents are happening, they are happening at a much higher baseline than what used to be a norm. And just to build on that particular point, this trend is not going downwards. Within quarter one 2026, we still see the incident count increasing. So the trend is continuing, and this is something problematic, right? This is clearly indicating that as more code is being produced by AI, as more output is being produced, so is the outages suffered by those particular software. And that is not an ideal place to be in. These two quarters, quarter two, quarter three of 2025, which saw major spike, are exactly the two same quarters where maintainability started to decline. So it clearly shows a trend that if it's getting harder to work with the code bases, then it's harder, rather that particular code bases become more exposed to incidents, and it's harder to recover from them. So on average, your time to recover from a software incident jumped from 2 hours to 22 hours. So that what used to take a few hours now takes excessively high amount of time because it's taking your reviewer in the cycle much harder to interpret that particular code. And that's exactly what maintainability measures.
Yeah, and to put that into some context, broadly, what we've seen, I think, across our customer bases in the early days of generative AI, about 3% of the coding effort was identified to be LLM authored code. That's now jumped up to above 10%, and with some of our heavy Gen AI using customers achieving closer to 20%. So AI is contributing and sharing to more and more of the code base, but not necessarily sharing the accountability, which is why it's so then critical that as the people that will take that weight on our shoulders, having the right data to predict and understand where those risks are becomes more and more important. If you're on the end of a call with an unhappy customer, sorry, the Gen AI did it, won't cut it. So it's so important to be able to pick apart where in our code bases we have these higher risks and be more proactive.
Absolutely. So just on building on that particular data, what you see over here is that if software incidents do happen in the most maintainable parts of the code bases, then the median time to recover from those incidents is 1.7 hours, right? And similarly, if those kind of incidents are happening in the most unmaintainable parts of your code bases, then the time to recover jumps to 65.2 hours, right? That's a 38-fold increase in your recovery time. And for that time period, your business is exposed towards the risk. Whatever your public facing application might be, it might be transaction processing, that incident is alive. And that 16% drop is explaining 38% of longer recovery times. And by the way, this is just a time to recover and deliver patch to an outage, right? The business consequences are far more wider than this, right? If this kind of a maintainability issues happen to be in your public facing application, then can you really afford for your system to be down for 65 hours at minimum? Right? It's easier to think that I have my maintainability problems. It's isolated to a single repository, but it's really important to see that the consequences of that poor maintainability are far more reaching and subsequently have a business impact. There is a widely published case study of Knight Capital where an erroneous flag triggered a dead code to run in production, triggering 460 million worth of loss because of those trades were executed, right? So if there is a dead code, if there are poor code-based practices, it's just not limited to your own repository. It materializes into inefficiency in your development practices, leads to higher outages in your production environment, and subsequently the business has to suffer because of that. So that is exactly why it is far more important to ensure where in my particular repository those unmaintainable files sit and fix them before they translate into a business issue. I think we had a poll.
We've got another
Hang
quick
on.
poll for you. This one is to do with AI. Obviously, everyone's talking about AI, so it would be really interesting to just hear what your view is on how AI is affecting maintainability in your code base. So again, just add your answer in the poll, and we'll keep chatting.
So, but do you want to take this?
Yeah, absolutely. So there's one question I just wanted to quickly address from Luke, which asked if the data was collected from both Europe and North America. So our global benchmark data set covers not just Europe and North America, but obviously a huge population in APAC, particularly in India, as well as the Europe and North America regions. A little bit of South America as well. So this is data from across the globe that we're sharing here. So in terms of how AI is ultimately affecting maintainability, so as we've seen, that increased output, that increased share of coding effort that we're seeing generated through the use of tools such as Copilot, Cursor, Klein, this is showing an increase or a decrease of 1.26 percentage points in overall code quality. And so that's leading to an increase in the amount of spend and investment that is required to maintain software. So sometimes there's expectations, right, that it's new features and improvements all the time. But actually it's about 60 to 90% of total lifecycle spend is on software maintenance, and technical debt specifically 20 to 40% of the estate. So what we can then see is that as we see more and more lower quality, less maintainable code is only going to compound these issues. So we see a 15% increase in defects in lower maintainability code as measured by Blue Optima that can take twice as long to resolve issues that come out of those less maintainable files. Ultimately, this can lead not just to more rework and needing more review, so longer code cycles and more time spent in correction, or as you might have seen in the Blue Optima UI, this coding effort that goes into rework. But in the longer term, from a developer experience standpoint, your teams are going to spend more of their time and energy firefighting. Obviously, increased stress, increased pressure, less innovation. So really leading to that idea of innovation theft, effectively. It'll compound over time. And so whilst we don't want to necessarily completely give a negative spin on AI, because obviously we're seeing those productivity gains, this really just does highlight how important it is to focus on balancing the quality aspect, because in the longer term, as we see that maintainability worsen, teams spending more and more time on firefighting and less time on the innovation work, my prediction is that an eventual decrease in productivity, because we're just not able to deliver source code in a maintained way anymore, and teams have to spend so much more time unpicking the spaghetti code that's led to the poor maintainability and the increase in production issues.
So fundamentally, we end up servicing more of the outages caused by AI rather than delivering the innovation, which very much Gen AI promised in the first place, right? So That is the future if the AI code is not used in more of a maintainable fashion. And just to build on that one as well, right? So for AI and for large language models to be very specific, context is everything that matters, right? And if the context for LLM is highly unmaintainable repository, then that's a bad context for the model, right? So you really want to make sure that your model, your large language models, are generating code that continues to be maintainable, rather than just further amplifying the unmaintainable debt that has been sitting in the repository. So before you bring in those kind of LLMs or start writing code using it, it's better to get the code in the nicest shape and form, and then build on top of it with maintainability as your guardrail to ensure that you are not moving just fast, but moving fast safely.
Yeah, absolutely. I think that's a really important point to touch on as well, in terms of, like, what should we be considering when we look at things like our context engineering practices. As if you put less maintainable context in, you'll get less maintainable context out. So looking at some of the best practices around not just I expect that any code authored by LLM should be well documented, well commented, pass the tests, but actually to specify best practices include, and then list how you want code to be structured, what principles you want it to follow, and even to use the Blue Optima data to give acceptable thresholds that LLM shouldn't deviate from.
So now that we had this kind of benchmark data, and just to recap, with the white paper that will be out soon, what we are really looking at is about source code data from 13 large enterprises and over 666,000 source code revisions. And we specifically established the link between software incidents and the source code changes that were delivered to patch that particular incident. And in this way, what we had a full understanding of how the source code looked like when an outage happened, and even before how the code looked like before an outage happened. And this way, we really wanted to answer one question. By just understanding the source code patterns and behaviors, can we figure out and flag what are the source code key risk drivers for software incidents? To put it simple, what are the key factors that causes a software incident to happen? And in this way, the benefit of that is that if we start noticing those kind of behaviors appearing again in the source code, those commits could be flagged for a reviewer to review before that they make into production, because we know historically a code commit like this has caused an incident to appear in the application. So this more of a becomes kind of a gate for you in the CI/CD pipeline. And in order to do so, in the paper we look at this from 5 different angles. We look into from the source code itself, from how the repository behaves, not just the code that was delivered to fix the incident, but also how the repository around that particular commit behaved. Was it a maintainable repository, or was it an unmaintainable repository in the first place? Then we look into how those changes diverge from each other. Are we comparing apples to apples or not? For example, are we not comparing a new application with a legacy application, and then also the human element, the PRs, the time it takes to review a change. So by looking into whole 5 different metrics, we were trying to understand, can we flag risky commits before they make into production? And then what we do end up with is a predictive model which correctly flags 3 out of 4 commits uh, before. Let me correct, 3 out of 4 dangerous commits before they make into production. And the another way of saying this is using our accuracy metric is that if as an engineering leader you say, I only have a limited time, can you flag me what are all those dangerous commits that I need to review before they made into production, because they are exhibiting the similar patterns as incident. The model would be 86% accurate in flagging and putting the right commits in front of you. So that is a great signal already that by using maintainability data points and the 5 different behavioral points around it, we could start flagging those commits in advance. And what then it outputs is a kind of a risk multiplier. And then if a risk is above 1, this is something that will be covered in detail in the white paper. But if it's above 1, then that's the probability of an incident happening in that particular file. If it's below 1, then that risk is being minimized by that driver. And about fundamentally the top 4 factors, let me mention, that came out was if you're delivering a highly unmaintainable source code, then the probability of an incident happening increases by 17%. Right? So that 17% is a huge signal for a software incident, and it's an immediate uh, action to take on those particular files. The second one again is whether that particular repository has been accumulating maintainability debt over time, right? So it's not just one change that you have made is unmaintainable. It's over time you have continuously delivered unmaintainable code that has now accumulated into repository tech debt, and that is exactly the second most important factor. So poor changes, poor maintainable changes are your leading indicator. And to build on top of it is your pull request lead time, right? So if it's taking much longer to merge pull requests, you are working with highly unmaintainable files, then the probability of an incident happening is statistical significant, right? So it is likely to happen given that these behaviors are being exhibited. And the last one is that if you are more so working with highly old aged files, right? So the files that have sitting in your repository, nobody has touched them in a long time. Uh, the world around that particular file has changed, but that file hasn't been modernized. That is yet another major risk. So if we start noticing these kind of risk patterns, it's critical to start flagging them within the repositories and prevent those changes from going into production before they materialize as a software incident. So with this kind of a predictive model in the coming days, we would be reaching out as well. So you will see this can fundamentally start helping you channel on where to focus to improve maintainability, and especially more so if it's a public facing application, then that's your immediate hotspot to resolve those particular incidents.
So to give some practical examples with how developers and teams have been using this data to good success. So we'll come on to the specific features within the user interface and the product that can achieve this. But to get the ball rolling, what we've seen is there can often be conflict between engineering and business in terms of what we need to be spending our time on. The push for new features, new stuff all the time, versus ensuring that we have the time and the capacity to address existing or newly introduced technical debt and poor maintainability. So what we've seen from an aggregate level is the use of the Blue Optima data to effectively prove the problem. So where we can see that decrease in maintainability within our own repositories, to use that data in aggregate to prove that the code base is moving in a direction that we would like to remediate. So if that is a hypothesis that you have about your overall code base and you have the opportunity to use the data to back that up, that's been used in great success to evidence the need not just to spend one sprint on resolving issues, but actually to build that into ongoing best practice, that we have capacity set aside and a backlog of tasks to improve maintainability as we go. So identifying those rogue files that might be significantly messier than a repo, the rest of the repo is one thing, but if you've got systemic health issues across your repo, that's not something that can be fixed in one sprint, but something that needs to be built into the team behavior and expectations from leadership on the capacity that's required to make those resolutions. I think importantly as well, often we'll get this question from teams, is that Blue Optima is not just measuring the coding effort that goes into new code. Refactoring and technical debt work also creates coding effort. And in fact, with some analysis that we've done across a couple of very large customers, particularly in the financial services space, teams that spent, I think it was around 20 to 30% of their coding effort on technical debt and rework and improvement tasks, were more productive than those that just did new features alone. So actually ensuring that you have a balance of those types of work can help to drive productivity, not actually count against it. That obviously then proves the problem at an aggregate scale. At a more detailed scale, it's then using the data at a more granular level, so looking at your individual files and then prioritizing those riskiest files that have the biggest impacts. So initially it can feel like boiling the ocean, especially if you work in a very large code base, lots of repos. So actually using that data to prioritize where you'll have the most impact, and sharing those issues through to task trackers like Jira can really help to build out that backlog and help you with prioritization, where's going to have the biggest impact with the least effort. And again, then coming back to that maintainability report. So if you've convinced the higher ups, you've got the buy-in to spend the time improving maintainability, being able to show that impact, show that maintainability trend improving back to where you'd like it to be, or ideally even better, gives you a quick way of showing the ROI and the impact that effort has had. So those would be very much sort of the best practices, I'd say, from our customers. At a more of a developer impact level, we've worked with a few clients to actually align rules in tools like SonarQube, for example, with the rules that are in Blue Optima, so that you've got consistency, or exporting those rule sets, having them on a Confluence page, including them as part of developer onboarding and training, so the requirements and the expectations for quality are really clear, not just in terms of a broad principle, but actually to have some numbers around it in terms of file sizes, numbers of methods, lines of code per function, just so it doesn't have to be overly prescriptive, but at least to give a sense of what's best versus very abnormal. So those would be some practical examples that you could think about as you start to improve your maintainability journey.
Thanks so much, Beth and Usman. That was so interesting and really great to see the data behind all of this. So now I'm going to pass you over to Guillaume, who's going to take you through how this looks when you're actually in your metrics and in the dashboards, and how you can start using your Blue Optima metrics to get the maximum value. So I'm going to pass over to Guillaume.
Thank you, Lula. So I'm sure right now all of you are convinced that maintainability is a key priority for your company. But how you can do it in our product? So for today's session, we have 4 main recommendations. The first one, you need to stop having a hero in your team. So don't rely on a single hero developer. Second is about, you need to have in your pipeline, you need to have quality checks. Another one, you will have to, Beth mentioned it earlier, you need to clean as you go, especially those rogue files. You need to improve them, otherwise you have some issue very, very soon. And the last one is your code review. Be really, really careful, because some of your developers, especially the junior one, they do some what we call the rubber stamp code reviews. Very quick, they do it, but it has a big, big impact. So if I go into a bit of details, and I will show you then in a product, objective of today is not to do an in-depth demo, but a bit of snack-sized best practices with Blue Optima. Regarding the hero developer, what we have seen is senior developers are 25 to 6% more likely to be involved in outage. What does that mean? It's not because they're careless, it's just that they're the only ones that people trust to touch the oldest and the most damaged code. Regarding the quality checks, is all those big production failures don't come from a single bad commit. Usually it's over time. Small bad code that's been introduced by every developer over a month and over years. And if you're not careful, if you don't check in your pipeline, and with Blue Optima, I'll show you in a moment how to do it, you will have quite some issues. Regarding the rogue files, I mean, we've all been there. I used to be a software engineer, especially in backend. You know those files that nobody touch, and usually it's all quite at risk. Please fix them. And the last one about approval, you do need to check like if someone in your team is clearly reviewing it, especially in an AI world. So how we can do that in Blue Optima? So for today's session, it will be mainly some screenshots. In the future, we'll have some dedicated in-depth meeting. So regarding point one, which is don't rely on a single hero developer. So how to do that? So I'm sure you're all familiar with Team Lead Dashboard, the product we are delivering to help your team leads to improve the performance of their team. The main page is Compass, which is what we call the headquarter. It's if you have one page you need to go as team leads is this page. At least once a week, you look at the performance of your team, what have they done, any issue. So regarding how to find a hero developer. So most of the time people think that a great developer, like productive, a very good code is a good thing. But in fact, it's not. It's a risk for you as a team. So how can you identify this? So I'm sure you're familiar with BC Day, which is the objective metric from Blue Optima to measure the performance of your team. We don't only deliver this metric at team level, but also at developer level. So if you want to identify a hero developer, so every time you go on the platform, you check the team productivity, but then you go on Compass and you have a dedicated developer view on the top when you click on See Trend. And you can review the productivity of each of the developers. And if you identify one specific developer that is above everyone, a good practice is to discuss with the developer, maybe to assign less productive work and to ask this developer to teach the rest of the team so knowledge is not concentrated into one person. That's one of the big risks you have as an organization. Second recommendation about quality checks. So will tell me how we can do that in the product. So I'm sure some of you are familiar with aberrant BC, which is what is the percentage of your intellectual effort that is bad code. So in Compass, we have a very nice and easy view where you can track aberrancy at team level and also at developer level. So same way as on BC Day, at the top of your dashboard, you have BC on the left, and on the right, you have all the different metrics, all the different behaviors you have to improve to be aligned with best practices in software engineering. So aberrancy is one of them, and it's not only to be a productive developer that's important, but also to have good quality. So you can check it in this view, month over month, to make sure there is not one specific developer that is producing very, very bad code, even if fast, especially in AI world. But also you're checking the code of every developer in this view. So how does that look? Very similar to BC Day. You have a dedicated view at developer level. Be careful if you don't have anyone very high. So what we recommend is between 4-5% aberrancy. It's the sweet point, what we have seen amongst all our clients. If you want a bit more detail, so when you stay in Compass, the section just after, you have what we call the execution view. You can have everything that be pushed by your team in a quantitative and objective way. So you can have all the AC, also all the code, actual coding for being produced by your team on which specific project, and you can have the aberrancy in all the commits I've done. So again, please take a very good habit of checking what I've done, as just to check the quality that have been produced. Right, next step. Beth, I've been mentioning that how we can detect rogue files. So I don't know if some of you have seen that we revamped a Maintainability page a few months ago. So now it's much easier for you to detect, to prioritize which file you need to fix. So in Team Lead Dashboard, you just need to go on Maintainability page. And here in a nice and easy way, we're able to show you all the files that you do need to fix. So first, at team level, again, you can track the Maintainability score of all the work that has been done by your team over the last weeks. An important thing that has been done is we're able to remove any non-core files. So test file, non-business file have been removed. You can see them if you want. Of course, there is a small filter, but by default, we'll show you only non-core only core files. And then what we'll show you is on those files. So here in the example is files that where you have someone working in your team. So it's quite easy to fix. We are telling you, we are helping you to prioritize what other file you do need to fix. And we are telling you the project is core improvement, so it can help you to prioritize. So I recommend, if you have any team list today, is once a day, just take an habit, once a week, sorry, you just book 15 minutes with team lead dashboard. You go on Maintainability, you look at all the files your team have been working on, and you prioritize the one you need to fix. There is one important item you may see on the screen. You see on the right, we have some magic runs, and there is one in particular on the second row. So this is what we call how to fix 2.0. So in this page in particular, we are providing some personalized recommendation. So instead of giving you generic feedback, we tell you exactly what's wrong in the file, but also what your developer needs to do. If you don't have this in your UI, as Beth was mentioning, please contact your favorite CSM or contact us at support just to enable this. But please keep in mind, this will help you to understand what's wrong in your file and prioritize it with your team. Next topic. We mentioned about how to avoid quite fake code review, just someone validate automatically, but don't really look at it. We'll have dedicated meeting webinar on this one, but if you go on Code Delivery, so Code Delivery is a page where we help you to improve cycle time, which is the time between the first commit and delivering to production. So here, in the same way that we do in Compass, leading metric, cycle time, and what are the different behaviors you need to improve. Again, we'll have dedicated meeting on this, but for today's session, what's important is we tell you first what good looks like. Really important. So how we do it, as Usman and Des were mentioning earlier, we do it based on data. We have hundreds of thousands of developer data, and we look at how do they behave. And we correlate that between, say, BCD and 70 different behaviors, and we have identified the best behaviors to maximize the productivity. And what we tell you is, all right, if I need to have some gate here to prevent not only quality issues, but bad code review, when you go on Code Delivery, you can, if you click on merge, you can see exactly all the pull requests you have. So we know that there is a lot of metrics here, so you can have like a very detailed view of what's happening. But we tell you, especially the PR time to close, it's a good signal for you to see if your developer really reviewing it correctly. And you can filter it and sort it to identify maybe this pull request has been done in 5 minutes, 4 minutes. It's not a real pull request, so please keep this in mind. I will conclude for the last item. We are moving to a world where AI is producing code. So at Blue Optima, we are building what we call the AI Trust Platform. We'll have dedicated meeting in the future, but please be aware that in the platform, my colleague and me will be contacting you. We'll put some banner, send some email. We have some very, very nice features coming where we'll be looking for some early access users, especially if you want to understand how to navigate a new world where AI is writing code, and also how to provide more insight, not only at senior engineering managers and team leads, but also at developer level.
Thanks so much, Guillaume. So I'm going to bring Usman and Beth back to answer some of your questions. If you haven't put one in the chat and you've got something you really want to know the answer to, add it now. So we've got a question here about aberrancy. Does aberrancy have any utility at a team level or only at an individual level? Should we be looking at maintainability at team level and higher, and aberrancy for individual coaching only? Who would like to start that?
Yeah, I can take that one. So it's a great question. Thank you, Ian. So I think they both have utility at team levels. The difference is maybe then how you would action them, or what you'd want to look into further. So aberrancy at a team level will give you a sense of the percentage of your current or recent coding effort that has been less maintainable. But in order to deep dive into that, you'll be asking yourself, who is delivering the aberrant coding effort? So it could be at a team level, it's medium, maybe let's say 6% aberrancy, 7% aberrancy. When you dig into that, if you have a layer of developers that are 1 or 2% aberrancy and a layer that are 10 to 13% making up your average, you maybe have that sort of almost single person risk that Guillaume was mentioning, where you've got a couple of developers that are delivering very high quality code, or perhaps are refactoring and improving other developers' code, and one population with the very high aberrancy, where the coaching and the expectation setting around quality would be really critical, so that we can bring people to a healthy medium. Whereas with the maintainability, it's less about the people perspective and more about the code base perspective. So at a team level, it will show you the maintainability of the files that your team is working on overall. You're then digging not into the people level, but into the file level. And this is particularly pertinent where you may have inherited files or repos from other areas of the business. So especially if you've undergone any reorganizations or a code base has been transitioned between teams, that maintainability aspect may have been introduced by people that you're not necessarily responsible for now, but you are responsible for the people that will need to then fix and improve it. So less of a coaching perspective and more of a prioritization effort. So both have value at the team level and then at a lower level of either file or individual, but you may be taking different actions or addressing those challenges in different ways, depending on what's causing the metrics to decline.
Thanks, Beth. Brilliant answer. We've got a question here about when Blue Optima will be integrated with IDE, so developers can directly see the impact of this metric during the coding PR process.
So this is, I can answer for this part. We are not sharing any fixed timeline, but you have to know that something will be contacting you in the short future. As at Blue Optima, we started our journey first with senior engineering managers, then team lead. And what we do currently is what we call shifting left. So delivering our value not only at senior engineering managers and team leads, but to developers. So it will be CLI and some plugins as well.
Thanks, Guillaume. Another question. So which AI vendor platform models do we use to analyze and serve up candidates for files in active development with issues, as well as the low effort fixes?
So to summarize the files in active development with issues, we're not actually leveraging an LLM or AI there. The way that we're identifying them is these are files that a person in your team has changed within the date range that you've defined. So in the maintainability report, if you set the date range to the last 4 weeks, we will show you files that a developer has changed recently, so based on commit dates, that have identified how to fix issue within them. And same for the low effort fixes as well. So we're not necessarily using AI there, but we have an algorithm that calculates an estimate of how much coding effort it would take to resolve the how to fix issues. Where the LLM and AI piece can come in is with how to fix 2.0. So if you are currently using just the how to fix 1.0, you'll see some fairly generic suggestions around, for example, this file has a high number of functions, try splitting the files to follow a single purpose principle. If you have the how to fix 2.0, which would leverage an LLM of your choice, so you can pick from a set of LLMs rather than us enforcing one on you, you can choose your LLM, which I think also may address one of the other questions. And that will be used to generate the how to fix 2.0 that wouldn't just say, split the file into multiple functions, but specifically look at this function or specifically split it and recommended in these 3 ways. So you'll get much more granular information with that LLM being integrated. But that LLM that you choose is totally up to you, because particularly with highly governance organizations, you've probably got 1 or 2 LLMs which are well approved. We don't want to introduce a third to the mix. It tends to take an awful lot longer to get things approved. So you can pick your LLM, and that's what Blue Optima would then use to generate those how to fix suggestions.
Thanks, Beth. A question here on how we identify code that's deployed to production for calculating cycle time. Is it based on Jira status?
Yes, that's correct. So this is based on the ticket itself. So that's really important for every commit that your developers put the Jira ID in the comments. That's how we can map the effort to the project. So with this in mind, you can quantify the effort that's been produced by your team by projects, but also the distribution of the efforts in your team versus new features versus technical depth. So that's really, really key. If you go in Compass, if you go on the section 2, which is execution card, you can see on the right there is a nice dashboard, so you can see the distribution of your team. So regarding the Jira status, you can decide which branch is the one that's moving to production. You have some setting you can push in CodeDev.
Thanks, Guillaume. I think we've got time for 1 or 2 more. So what are the guidelines and who is in charge of setting up excluded commits or files?
Yes, so there is no single person in charge of this. There is not a sort of Blue Optima person that's clicking through and saying, I fancy excluding that one. This is all based off of data. So the exclusion criteria that get set out for specific commits are visible in the team lead dashboard. You can see why particular commits have been excluded. So if you see the included versus excluded column, there'll be a little number in blue. It is hyperlinked. If you click that number, it will show you all the individual commits with their exclusion reasons. Those are based off of kind of key patterns to identify if this was, for example, a merge commit, or if there is a significant deviation. I think it's if a particular commit is 3 times higher than the standard deviation for a commit size, that gets flagged as, for example, a mass change. If you think that there is a mistake and that a commit should be included, then you can always raise that with support@blueoptima.com. Really helpful if we can get the commit hash, who made it, and ideally some context about what that commit was doing, like what was the purpose of the change. Then we can see if that was an incorrect predicted exclusion or not. But very good practice just to look at the exclusion reasons initially and see if that matches up. So merge commits are a great example of this. The original commit would be included, subsequent merges wouldn't, so that we don't duplicate or triplicate effort.
Great, thank you, everyone. If you have any more questions, as Beth said, do reach out to your customer success manager or to us, and we will pass you on to the person that's relevant. We've got 1 more poll. We'd be very grateful if you could just give us your answers so we can make sure that the next webinars are as useful as possible. And you will be getting the recording and the deck in an email, so look out for that in your inboxes. So thank you so much for joining. I hope you found it useful, and yeah, your feedback will really help us guide the next in these series. We've got lots of really interesting stuff planned for you, and keep your eyes out for the maintainability white paper as well. Thanks, everybody.
Thank you, everyone.
Thank you. Thank you, everyone.
Fantastic. Thanks all.